Imagine you are sitting by the window of an imaginary spaceship, quietly drifting through the endless night, where stars sparkle like specks of diamond dust scattered across a gigantic black velvet tapestry. Earth, our beloved home, appears as a fragile blue orb, suspended in the boundless ocean of the universe without borders. That is where all your loved ones are living, where every joyful and sorrowful story has unfolded, from the first smiles of childhood to the tears of farewell, all encapsulated in that tiny speck. That sensation makes your heart tremble, a surge of emotion rising as you realize the preciousness of this planet, where humanity's journey began and where dreams of conquering distant horizons are nurtured. Now, let us allow our minds to zoom out, departing from the warm atmospheric blanket enveloping Earth, soaring through fluffy white clouds, passing the familiar moon, then venturing even farther to the radiant sun, and continuing this epic journey to grasp the true scale of the vast universe. As we leave the safe embrace of Earth, the first landmark to greet us is the Moon, our loyal companion approximately 384,000 kilometers away. Try to picture it. If you were driving an ordinary car at a steady speed of 100 kilometers per hour without any stops, you would need more than 160 days continuously, that is over 5 months of relentless travel on the road, to reach the grey, crater-pocked surface of the Moon. From that vantage point, Earth emerges as a delicate sphere, rotating with swirling bands of deep blue oceans and lush green forests, cradled in the pitch-black, frigid void of space. This sight makes you feel insignificant and humble, as if all of human existence is merely a fleeting breath in the eternal expanse. That is the view of Earth from the Moon, a painting that evokes profound emotion about the fragility of our shared home. Recent observations from lunar orbiters, such as those conducted by the Lunar Reconnaissance Orbiter mission launched in 2009 and still operational in 2025, have revealed intricate details of the Moon's surface, including permanently shadowed craters that may harbor water ice, essential for future human exploration and potential bases, highlighting how this close neighbor could serve as a stepping stone for deeper space ventures. Continuing our adventure outward, the next milestone is the Sun, the colossal star approximately 1 astronomical unit away from Earth, a standard measure in our solar system equivalent to 150 million kilometers. Consider the sunlight traveling at the blistering speed of 300,000 kilometers per second, yet it still takes 8 minutes and 20 seconds to traverse that distance and illuminate Earth, bringing the warmth that sustains life. If you attempted the journey in a commercial jet airplane at 900 kilometers per hour, you would require about 19 long years. Envision those years slipping by amid the constant hum of engines and the whistle of wind outside the window, before arriving where the sun blazes in all its glory. This immense distance reminds us of the vastness even within our own cosmic backyard, where the sun, a gigantic ball of fire with a surface temperature reaching 5,500 degrees Celsius and a scorching core of 15 million degrees Celsius, provides the energy that maintains all life on Earth from that remote position. According to the latest studies from the James Webb Space Telescope, launched in 2022 and actively observing through 2025, the Sun is not merely a light source but the epicenter of powerful magnetic storms that influence Earth's climate and technology. For instance, in mid-2025, the telescope combined data with the Chandra X-ray Observatory to visualize dark matter structures in the solar system, revealing how solar flares can disrupt satellite communications and power grids, while also capturing detailed auroras on Jupiter, our largest planetary neighbor, demonstrating the interconnected dynamics of the solar system that extend far beyond our immediate surroundings. Departing from our home planet and its solar companion, we turn our gaze to Mars, the enigmatic red planet and Earth's closest neighbor. At its nearest approach, Mars is about 54.6 million kilometers away, but when the two planets are on opposite sides of the Sun, the distance can stretch to 401 million kilometers. To better visualize, traveling by that commercial jet at the aforementioned speed would take 50 years, a half-century filled with repetitive in-flight meals and fitful sleeps amid the clouds, to touch down on the dusty reddish-orange surface dotted with ancient volcanoes like Olympus Mons, the tallest mountain in the solar system at 22 kilometers high. The vast emptiness between Earth and Mars poses a monumental challenge for exploration, with probes like NASA's Perseverance rover, which landed in 2021 and by 2025 had collected hundreds of rock samples in search of ancient life traces, facing not only the distance but also ever-shifting orbits that demand calculations precise to the second. Mars, with its global dust storms that can engulf the planet for months, evokes the image of a desolate yet promising world where humanity dreams of establishing colonies in the near future. According to SpaceX plans updated in 2025, uncrewed Starship missions are slated for launch in 2026 to test landing capabilities, paving the way for crewed flights by the early 2030s, with the rover's recent discovery in September 2020. 5 of potential biosignatures in Jezero crater rocks from an ancient riverbed providing the strongest hints yet of microscopic life, igniting excitement about microbial fossils that could rewrite our understanding of extraterrestrial biology and accelerate colonization efforts. As we push farther to the edge of the solar system, we encounter Neptune, the distant icy giant approximately 4.5 billion kilometers from Earth. Sunlight must race through the frigid vacuum for about 4 hours and 15 minutes to reach this deep blue planet, where winds howl at speeds up to 2,000 kilometers per hour, fiercer than any storm on Earth. This astonishing distance underscores the immensity of the solar system, and Voyager 1, launched in 1977 as a testament to human curiosity, has journeyed over 4 decades to arrive here. By 2025, Voyager 1 has traveled more than 22 billion kilometers from Earth, becoming the farthest human-made object, a silent wanderer in the cosmic sea, transmitting faint signals across the silent void, now at approximately 25 billion kilometers or 169 astronomical units, with engineers in 2025 restoring partial functionality after communication glitches to continue gathering interstellar data. In 1990, at the suggestion of astronomer Carl Sagan, Voyager 1 turned its camera back to capture its final image, Earth appearing as a pale blue dot 6 billion kilometers away, faint in the vast universe. Carl Sagan reflected poetically on that photograph, reminding us of our duty to cherish and protect this tiny planet, merely a mote of dust in the cosmos, a message that resonates even more today amid growing concerns over space debris and the need for sustainable exploration. At the solar system's fringe lies the Oort cloud, a theoretical gigantic sphere surrounding it composed of countless icy bodies, believed to extend up to 100,000 astronomical units from the Sun, equivalent to about 1.9 light-years. According to the most recent astronomical models from 2025, informed by data from the New Horizons mission that flew past Pluto in 2015, this cloud is the origin of many long-period comets, with ancient ice chunks carrying secrets from the solar system's infancy. A study published in early 2025 revealed that the Oort cloud possesses a pair of spiral arms resembling a miniature galaxy, suggesting dynamic gravitational interactions that could influence comet trajectories and even distant stellar encounters, while New Horizons, extended into 2025 for heliophysics observations, continues to probe the outer reaches, providing data that refines these models and hints at the cloud's role in seeding water and organics to inner planets like Earth. This is the frontier where the Sun's influence wanes, and the heliopause, the boundary between solar and interstellar space, marks where the solar wind is halted by the interstellar medium. Voyager 1 crossed the heliopause in 2012, entering interstellar space and ushering in a new era of discovery, with ongoing measurements in 2025 revealing plasma densities that challenge previous assumptions about the local interstellar environment. Venturing beyond the solar system, our next stop is Alpha Centauri, the nearest star system approximately 41.3 trillion kilometers away, equivalent to more than 276,000 astronomical units or 4.4 light-years. At this scale, the astronomical unit becomes impractical, so we employ light-years, the distance light travels in 1 year, nearly 9.5 trillion kilometers. With current technology, Voyager 1 cruising at 17 kilometers per second would take over 70,000 years to arrive there, envision thousands of generations passing aboard such a vessel. Alpha Centauri comprises 3 stars, Proxima Centauri, the closest, orbited by the potentially Earth-like Proxima, be discovered in 2016, and according to 2025 updates from the Euclid telescope, there are signs of a possible atmosphere with water vapor and carbon dioxide, bolstering habitability prospects. Further, the James Webb Space Telescope in 2025 provided strong evidence of a giant planet in a nearby solar twin system, inspiring advanced instruments like the Ristretto spectrograph to constrain Proxima B's atmosphere, orbit, and albedo, potentially confirming biosignatures within the next decade through high-contrast imaging that separates the planet's faint light from its flaring host star. Our journey now leads to our home galaxy, the Milky Way, a colossal spiral approximately 100,000 light-years in diameter, harboring hundreds of billions of stars, each potentially with its own planetary system. Within it, humanity's radio bubble has expanded only about 100 light-years from Earth, carrying radio waves from the first television broadcasts in 1930. Beyond that bubble, humanity might as well not exist. Our history is but a faint whisper in the cosmic wind, a reminder of how young and localized our presence is amid the galaxy's ancient stars and black holes. Leaving the Milky Way, we step into intergalactic space, where it belongs to the local group, a cluster of more than 50 galaxies spanning 10 million light-years, including Andromeda 2.5 million light-years away, hurtling toward us at 300 kilometers per second, set to collide in 4 billion years. Light from one end of the local group to the other takes 10 million years, rendering everything in the galaxy obscure in cosmic timescales, with mergers like the future Milky Way Andromeda event expected to reshape star formation and dark matter distributions based on simulations refined in 2025. Expanding further, we encounter the Virgo supercluster, a vast collection 110 million light-years across containing thousands of galaxies from at least 100 groups. Then comes the Laniakea supercluster, stretching over 500 million light-years with a mass of 100 quadrillion suns, encompassing the Great Attractor, a high-density region pulling galaxies toward it with immense gravitational force. In this structure, the Milky Way is but a grain of sand, dwarfed by filaments and voids that form the cosmic web. Finally, the observable universe spans a diameter of 93 billion light-years, though its age is only 13.8 billion years due to expansion from the Big Bang, according to the Lambda Cold Dark Matter model updated in 2025 with Planck satellite data. These refinements address the Hubble tension by incorporating evolving dark energy, where recent analyses from the Dark Energy Spectroscopic Instrument suggest deviations from constant dark energy density, potentially inspiring new physics beyond the standard model, while galaxy maps from 2025 challenge uniform expansion assumptions, hinting at anisotropic features that could redefine our understanding of the universe's large-scale structure. Beyond this, countless galaxies recede faster than light, forever beyond reach, leaving us with profound humility before the potential infinity.